Hello friends, myself R D Mahajan, Assistant Professor, MIT Aurangabad, presenting my video on the topic Dirac-Delta function from Laplace Transform. Unit 1 Laplace Transform of Engineering Mathematics 3. Figure, on x-axis we are taking the values of t, on y-axis we are taking the values of f of t. This strip is in between a to a plus epsilon. Epsilon is very small quantity and the value of that function is 1 by epsilon. Compared with the value of epsilon, 1 by epsilon is very large. Therefore, if large force is acting for short duration or short time, then that function is called as unit impulse function. This is called as unit impulse functions, or another name for that is Dirac-Delta function. Therefore, this figure is representing that unit impulse function or Dirac-Delta function, which is acting for a very short duration, and that large force 1 by epsilon. If epsilon is very small, 1 by epsilon becomes or tends to infinity or tends to a large amount, and therefore if large force is acting for short duration, then that function is called as unit impulse function, or another name for that is Dirac-Delta function. It is a limiting function. Therefore, if we take a limit of f of t as epsilon tends to 0, then it is called as delta of t minus a, or Dirac-Delta function or unit impulse function. It is defined as delta of t minus a having three values: 0 for less than a, t less than a. Second value is 1 by epsilon. This is 1 by epsilon for the value of t in between a to a plus epsilon, and again after a plus epsilon or t greater than a plus epsilon, its value is 0. Therefore, this is the definition of that Dirac-Delta function. Okay. As epsilon tends to 0, the value of the function becomes infinity. 1 by any large number that tends to infinity or becomes infinity. Delta of t minus a, that unit impulse function having two values, infinity for t is equals to a and 0 for t less than, t is not equals to a. And the area of that strip, which is obtained by performing this integration between 0 to infinity of delta of t minus a with respect to t, is 1. Therefore, remember this definition for that delta t minus a, known as Dirac-Delta function or unit impulse function. Then we try to see the Laplace transform of that Dirac-Delta function, and then we try to solve some problems on that Dirac-Delta function. Laplace transform of Dirac-Delta function, delta of t minus a, is given by e raised to minus as. Its value is e raised to minus as, and when a equals to 0, we get Laplace transform of delta of t if a is 0, and if you put a equals to 0, it becomes e raised to 0, and e raised to 0 is 1. Therefore, these two important results from this. Then one more result, Laplace transform of f of t multiplied by Dirac-Delta function delta of t minus a, and it is given by e raised to minus as into f of a. F of a means value of that function at t is equals to a. Therefore, these are the important results from this Dirac-Delta function. Then we try to solve some problems. Example 1, find Laplace transform of t square into delta of t minus 4. And to find this Laplace, we try to apply this, and therefore solution to this problem, Laplace of t square, that function f of t is here, t square, delta of t minus 4, t minus a is here 4, is equals to e raised to minus as, a is here 4, therefore e raised to minus 4s into value of the function at t is equals to 4, and therefore value of this t square at t is equals to 4, and therefore we have e raised to minus 4s into 4 square is 16, and therefore that value is 16 into e raised to minus 4s. Then second, find Laplace transform of e raised to 3t into delta of t minus 2. Solution to this problem. Here f of t into delta of t minus a, therefore we have to apply this result. Therefore, Laplace transform of e raised to 3t into delta of t minus 2. We can use this result, or we can use first shifting theorem, as this function is multiplied by e raised to a t type of term. Therefore, I am using first this one. Therefore, as per this, it is e raised to minus as, a is here 2, therefore e raised to minus 2s into f of a, here f of t is e raised to 3t at t is equals to a is here 2, and therefore we have this one as e raised to minus 2s into, put the value of t as 2, we get 3 to the 6 into e raised to 6, and therefore if we simplify it, it becomes e raised to, we can base system, we can add the power, and therefore it is 6 minus 2s is the Laplace transform of that function. Or we can go by first shifting theorem, or we first find the Laplace of this. We know that Laplace transform of delta of t minus 2, as per this result, it is e raised to minus as, a is here 2, therefore e raised to minus 2s. We call this as a bar of s, and therefore by first shifting theorem, Laplace transform of that term is e raised to 3t into delta of t minus 2 is equals to replacing s by s minus 3, and therefore it is equals to e raised to minus 2 times s is replaced by s minus 3, and therefore we have it is equals to, if you simplify it, 3 to the 6 e raised to 6 minus 2s. Therefore this is by direct applying this result, and the second way, another way, by applying first shifting theorem. The result is same, e raised to 6 minus 2s, or for this e raised to 6 minus 2s. We can use any method to find the Laplace transform. Example 3, find Laplace transform of cos t into delta of t minus pi. Solution for this problem. Here f of t into delta of t minus a, applying this result, we have Laplace transform of cos t into delta of t minus pi is equals to e raised to minus as, a is here pi, therefore e raised to minus pi s, into value of the function at t is equals to pi, that function is here cos t, at t is equals to a is here pi, and therefore it is equals to e raised to minus pi s into cos of pi, and the value of cos pi is minus 1, and therefore we get that value as minus e raised to minus pi s is the required Laplace transform. Next example, find Laplace transform of e raised to minus t sin t by t into delta of t minus 3. And therefore, once again, the problem is of this type, Laplace of f of t multiplied by Dirac-Delta function. And therefore, using this result, we have Laplace transform of that function is e raised to minus t sin t divided by t multiplied by Dirac-Delta function delta of t minus 3. Here a is 3, and therefore as per this result, it is e raised to minus 3s into value of the function at t is equals to a is here 3, that function is here e raised to minus t sin t by t at t is equals to 3. And therefore we have, if we put the value for t as 3, it becomes e raised to minus 3 sin 3 divided by 3 into e raised to minus 3s is the required Laplace transform. Okay. Next example, last example, find Laplace transform of sin 2t multiplied by Dirac-Delta function delta of t minus pi by 4 minus t raised to 4 delta of t minus 4. It is a combination of this type of two terms, and therefore we try to find out Laplace of first term minus Laplace of second term. Therefore, I will first find Laplace of sine 2t into Dirac-Delta function delta of t minus pi by 4, and it is equals to, as per this result, it is e raised to minus as, a is here pi by 4, therefore e raised to minus pi by 4 s into value of the function at t is equals to pi by 4. That function is here sine 2t at t is equals to pi by 4, and therefore it is equals to, if we put t as pi by 4, it becomes sine 2 times pi by 4. 2 to get cancelled, it becomes sine of pi by 2 into e raised to minus pi by 4s. And the value of sine pi by 2 is 1, and therefore it is e raised to minus pi by 4 times s. We call this as equation 1. Then we try to find out the Laplace for the second term. Laplace transform of t raised to 4 into Dirac-Delta function delta of t minus 4 is equals to, here a is 4, therefore e raised to minus as means e raised to minus 4s into f of a means value of this function t raised to 4 at t is equals to a is here 4, and therefore it becomes 4 raised to 4, 4 raised to 4, 4 into 4 into 4 into 4, that value is 256 into e raised to minus 4s. We call this as equation 2. And then if we substitute two values here, we get the Laplace of this function, and therefore Laplace transform of sine 2t multiplied by delta of t minus pi by 4 minus t raised to 4 delta of t minus 4 is equals to equation 1 minus equation 2. Equation 1 right hand side term is e raised to minus pi by 4s minus Laplace of the second term, and Laplace of the second term is 256 times e raised to minus 4s is the required Laplace transform or required answer. Therefore, with the help of all these 5 simple examples, I explained how we can find the Laplace transform of Dirac-Delta function, or how we can find the Laplace transform of Dirac-Delta function multiplied by any function f of t. And for that we are using this result. Its Laplace is equals to e raised to minus as into f of a. F of a means value of the function f of t at t is equals to a. In my next lecture, in my next video, I will explain how we can find inverse Laplace transform of this Dirac-Delta function. How we can use this term while solving the differential equation containing this unity impulse function or Dirac-Delta function. If you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates. Thank you. Thank you.